Good morning and Assalamu alaikum. We have today's very important lecture, utilization of peanut byproducts for valuation. So this shall be delivered by Dr. K.BEMBEM. She is a scientist in ICAR Ludhiana, which is a very premier institute when we talk in terms of engineering and technology. So very premier institute. So I request Madam to kindly come and deliver the presentation. Thank you, ma'am.
Good morning, everyone. I'm Dr. K.BEMBEM. I'm working as a scientist in ICAR in the Transfer of Technology Division. I'm basically a home scientist. My elective is in food and nutrition. But after coming to ICAR, Sir was already introduced, it's like an engineering institute. Like many of you must be aware where ICAR is. Okay. So to give a brief introduction about myself, I got through this ARS examination in 2016 after my PhD. In PhD, Dr. Jamir and I were kind of classmates from different divisions. We had some common courses. And then since 2016, I'm in ICAR. Currently, I am in the senior scale, so kind of simply a scientist. I believe that this group is a mixed group from different disciplines.
Mostly they are from food technology background, but they are from different universities.
Okay.
We have 3-4 universities in Jammu and Kashmir offering food technology, so they are from different universities.
Okay.
But mostly all are from food technology.
Okay. So you are a PhD student or a master's? Okay.
ICAR.
Only girl students are here or boys are also here?
We have, in university itself, we have about 80% students, female students.
Okay.
So in food technology, we have about 95% female students.
So women empowerment has to be changed. It is always happening.
Please,
Okay, sir. I have given a very short presentation. It's a 1 week course, right, that you are doing this entrepreneurship. So by this time you must be aware what circular economy is. Yes. What it is.
To give more value to the product and to utilize its waste.
Okay. Maximum utilization of the byproducts. That is circular economy. Why economy? Because we want to make efficient utilization of the resources and get the maximum value out of the products or residues that we get. So, what do you call peanut here?
Gel rose.
Gel rose. Okay. My pronunciation might be different, but it's okay. Peanut is very common. So peanut or groundnut, it is quite common in India. And what are the different products that, not the byproducts, it is that products itself that you can think from peanut butter. Other than that?
Peanut nut butter.
Okay. Okay. And you miss one very important thing. More than 50% of the peanut is used for oil production. So today I'll be dealing with the utilization of peanut byproducts for value addition. Okay. So coming in general, what agro-food waste is, since your entrepreneurship title is on agro-food waste, I have kept a brief introduction. Food waste, it is all food that is compromised in quality or quantity or in safety. That is categorized It differs from consumer to consumer. It may include fresh products from the production chain, and food close to expiration dates, food discarded by the retailers, and food products from household kitchens and other establishments. Why it causes environmental, social, and economic issues?
Waste. Because we discard waste in the open yards.
Yeah.
There are chances of more diseases, the creation of segregation, creation of gas,
Yeah.
contributes to the society in a hazardous way.
Yes. And also nowadays, since people are getting more aware of the environment, pollution, this and that is why we have this issue. So the FAO reports that like 17% of the total food production, it goes in the West, and of that production, 14% is lost during the production chain. So it is kind of waste and then lost. The difference, do you know the difference between food loss and food waste? Yeah, that like it is that one. So, pointer? Pointer? Otherwise, pointer. So of the total food production, the wastage is this much: 14% as waste and 17% as waste and 14% as loss. So of the total loss, 21% come from dairy, maximum from beverage industries, fruits and beverages, fruits and vegetables, grains, meats. This pie chart shows how much is the contribution. You can stop me in between if you want to ask anything. So by now you must be aware that food, like agro-food waste, it is not a waste anymore. It is a resource. So in the vegetable waste includes peels, stems, sheets, shells, bran, pulp, and other residues. And from the animal sources, wastage comes from the animal husbandry, dairy processing, seafood, and slaughterhouses. So it can be byproduct, waste, or residue. Can you differentiate what is the difference between this byproduct, waste, and residue? You can just try. What do you think?
For example, when we go for the processing of, or when we are going for the milling of the wheat, so we get different products like salmon, we get that suji, so that is a byproduct, right?
Okay.
So, for example, whatever is left, which is not processed further, it is categorized as a residue, which remains over there for the processing. And waste is something after the processing, and when we consume it, whatever is, we are not using that, or consuming that is a waste. So,
yeah, true. A byproduct is something which comes as a part of the production. So, like this byproduct, it can be industrially processed to further product. Waste is something which is intended or discarded, but it can still be used in the circular economic term approach. And residue is something which, like in the, as you have given an example, it's the dust, dirt kind of after pulse processing. So this waste or byproduct, it is now a potential source of value-added compounds. And why today we are discussing peanut? Because it is a very high protein and oil source. It is very nutritious, and that it is also called longevity fruit because of the high nutrients that it has. It has got about 20 to 25% protein, 40 to 50% oil, and many minerals. And one important vitamins that is found is the niacin. Yeah. It is kind of antidepressant. It is also an inexpensive source. So the production in India alone is around 8.3 million tons. So 83, we have this much of production. And the production in India is just next to China. So how do we utilize? We have already discussed this. So 50% of the total production, it is used for the oil extraction, and the 35% for human consumption, directly as for human consumption or in confectionery, or like here comes the peanut butter that you have mentioned. And the remaining 15% as seed or for animal. So from this many, if you utilize this, there will be byproducts. So these byproducts, like from the shell to like for every kg of peanut, there will be around 20 to 30% of shell, or even more, up to 35 to 40%. And skin, about 3%. And the peanut meal, which comes from the oil extraction, it is about 50%. So this is how the utilization SIN is. So the circular economic approach, we have the byproducts, mainly the cell, skin, and the milk. So these byproducts in the circular economic approach, it can be used to generate lots of biochemicals using different extraction mechanisms. The first and foremost thing in any process utilization and value addition of the bioproduction is through extraction procedure. The first thing is the extraction. So these biochemicals, it has got high bioactive compounds, it has got carbohydrates, polysaccharides, proteins, lipids, and other essential oils. This has application in the food industry as antioxidants, biofilms, antimicrobial activity, and colorant, even in the food and the textile industry. So this is the circular economic approach for the peanut byproducts. This peanut cell, it has got high fibers and bioactives in addition to the protein, lignin, hemicellulose that it has got. And in the rectangular box is the application. It can be used for biofuel production, paper production, water treatment, and bioabsorbents for heavy metals, for water filtration system, and it has got food application as well. And the skin, which is the pink color, it is non-toxic and it is used for food application, dye. And the peanut meal, which comprises of about 47%, almost 50% on a dry weight basis. It has 50% protein in the meal. So it is used for food application and for the protein hydrolysis preparation. Coming in detail, the peanut cell, this many million tons of peanut shell is produced worldwide, 9.2. And it has got very slow degradation rate. This is a picture that I took from the internet, okay? And it is sold as such for the different uses. It can be used for animal feed, manure and compost, biofuel and energy source, and industrial absorbent. And this, since it has got high fiber, it can be applied for human consumption as well. Here is the peanut skin. Another picture that I have taken from India Mart. It is readily available, the extract, the peanut skin extract, since it has got important valuable compounds. So 0.94 million ton is produced worldwide. It is still a very high. These are very high antioxidants. So it has got high market potential as well. Here comes the peanut milk. It is very proteinaceous. This is the byproduct of the oil extraction. It is also called peanut meal or cake. About 8 million ton is produced worldwide. And I have already told defetted peanut milk contains almost 50% of protein, so it's a high protein source. And most of it is used for animal feed or for fertilizer. So coming to the this is the biorefinery approaching peanut byproduct. The first block is the definition what biorefinery is. Have you come across biorefinery anywhere? So it is defined as the sequential process integration for the conversion of biomass into energy and a variety of byproducts, biofuels, and value-added co-products. So it is biorefinery. In other terms, it can be said that like you have a byproduct. You are utilizing that to a maximum extent with the use of other non-conventional methods as well, with the use of microwave-assisted extraction, ultrasonification, pressurized liquid extraction, that kind of thing. So in a greener term, if you use this, like these solvents and different solvents, if they have different polarity and different, so the extraction becomes more. And since we are using this circular economic valorization kind of thing, we are trying to use maximum, take out maximum out of it. So the recovered compound is also varied, since we have used different, the byproduct that we get from one byproduct, it is still used for another. So nothing is wasted. Coming to the composition of peanut cake or meal, this table shows how much protein. This column is for protein. So it has got very high protein. All the cake after extraction of oil, and highest is in groundnut and soya meal. And most of this meal, these are used for animal feed, 60%, and organic manure, 10 to 15%, and it is exported in tons and tons. These are some protein concentrates, protein isolates, protein hydrolysates that we find in market. So coming to how we can use that biomass, byproduct meal, especially the meal, for human consumption, it can be through the protein enriched flour, the protein concentrate, or the protein isolate. These are all available in the market as well. And the global forecast for plant-based protein market is that it will, from 2023 to 2028, it is expected to rise at a rate of 7.7% CAGR. So, and it is quite high in the Asia Pacific region. The forecast is very high, so it has got market potential. And it has got attractive opportunities for the plant-based protein. Why people are going for the plant-based protein?
Because people are avoiding beef and all and going to vegan.
Yes, veganism, people are doing that. And it is given there as well, the same thing that you have mentioned. So what is protein isolate? It is the most concentrated form of protein available. It contains over 19% protein on a moisture-free basis. You are aware of the dry basis and the wet basis? So on a moisture-free basis, it is comprised of 90% protein. And this protein isolate, it is free of odor, color, anti-nutritional factors, and then flatulence providing compound. The high protein concentration provides maximum formulation flexibility to be incorporated in the food applications. And it has applications in meat analog, texturized vegetable protein supplements, and even in infant foods as well.
The one you mentioned right now about protein isolate, are we getting this isolate from the ghee or the peanut or
From the cake, we are using the peanut milk cake.
Yeah.
Yeah. We are using this from the byproduct. So this is one methodology for the extraction of protein isolate. This flow chart. With the use of this enzymatic method, this already available. It is already available in literature as well. It can be extracted through chemical process and also with the application of enzymes. So with the application of enzymes, it is better. This is a CFAT technology. So with the use of this enzymatic extraction, the product feature has got probiotic properties. It has got better appearance, longer shelf life, and the list continues. These are two technologies of CFAT for the production of plant protein. Number one is the microbial method for production of protein isolate or concentrate from oilseed cakes and meals. Technology for production of rice bran protein. Since plant protein demand is on rise, we have this kind of thing. Another byproduct that, now I'm talking about the CFAT technologies that we have. This is the peanut milk byproducts. You must be aware of the peanut milk, like the soya milk. So likewise for the peanut, we can extract milk from the peanut. And the procedure is almost the same for the production of soya milk and the groundnut milk. It is the, you know how it is produced? Soya milk or peanut milk? Yeah, it is the, has anybody of you come to CFAT before? Okay. It is the, I'll tell you in brief how peanut milk is produced. The process is the same for groundnut milk, soya milk. So what happens is you soak the peanut for some time in hot water, 5 minutes in hot water, and then you crush it. Then you get a mixture. So that mixture is cooked. It is done in a plant, but it can be done in the household conditions also. The crushed peanut is mixed thoroughly with water. At the ratio of 1:6. 1 kg of peanut and 6 liters of water you add. You crush it thoroughly. You get the mixture, the slurry. When it is filtered, the water, the filtrate that it comes is the peanut milk, and the residue that you get is the okara. So it is the same for soya also. Okara, yes, peanut okara or soya okara. The residue is the okara. So this okara, I'll come further. When you process 1 kg of peanut, you get around 6 to 7 liters of milk, and the remaining you get around 500 grams of okara. And then why I say tofu here? tofu whey. Yeah, plant-based protein.
Soya.
Yeah.
After coagulation of soya.
After coagulation of the milk, you get this tofu. So in the process, you get a lot of whey. This whey is still very high in protein and also fat. And in the process of production of the peanut milk, you can separate the cream as well. So these are the different byproducts in the processing of peanut milk. So from this table you can see how much moisture, energy, carbohydrate, protein, total fat are present in the peanut milk and their byproducts. In the whey itself, we have got high protein and carbohydrate. So why it should be wasted? It should still be used, right, in the circular economy approach. So we are in the okara, how much of the nutrients are there, you can see from this table. So we are trying to utilize these byproducts as well. So these byproducts, it can still be used in bakery and confectionery with about up to 50% substitution. You can store the okara after dehydration and then be used in substitution in flour and for the different product formulation. Up to 50% substitution has been reported in research papers. Then comes the beverages with up to 40%, like you can add up to 40% of fruit pulp to add flavor. And the cream that you get can be used for ice cream, salad dressing, and icing of cake. So, in conclusion, I would like to say that since peanut is getting popular, the global market is warming for it, and as a result, the byproduct produce is also increasing. So we can use maximum of the byproduct. So with exhaustive recycling and reuse of the biomass, so that we can get more out of the byproduct. That is all. Thank you. That is how we can generate more income and produce less waste and more of greener technologies. If we use, the pollution will be less, landfill will be less filled, and resource generation is high.
Now, you just showed us one of the slides where you mentioned about the different technologies, right?
Yes.
There was one column in that slide, where you mentioned licensing fee.
Okay.
What are those?
We have, since CICAR is a research institute, we sell our technologies with licensing fee. Licensing fee is I have the technology. If I want to sell it to someone, I get some money for that. That is the licensing fee.
So these are for example, somebody has optimized some procedure or process.
Yeah.
So that's kind of patented or something, and then you sell it to somebody else.
No, you can sell the technology before you go for the patent also. Once you go for the patent, it's the process is long. So before that, if you want the farmers or the people to use it, you can go for licensing of this before the patenting also. Anything else? Yeah. These allergens are protein. These are H1 to 9. Yeah. Like the total elimination is not possible. Allergen that comes from that gene is not possible, but the toxins that we get from this aspergillus and penicillium, this can be reduced through it will be reduced through these many different processes. Those allergens cannot be removed totally. Further questions? Related or unrelated to the presentation, you can ask anything. Okay then. The shortest presentation of all I think.
This was a very good and nice presentation by Dr. K.BEMBEM. Sorry if I'm not pronouncing it correctly, forgive me for that. So I think the presentation, she gave an overview about the peanut processing and its byproduct utilization, and I think this might have enhanced your vision if you really want to go for the rare valorization of other products other than peanut. So you can adapt the same type of technology or same type of the methodology, but they have adapted at this effect. So I thank you once again, ma'am. Thank you. Yeah, moment to